Welcome to the lesson 17 of the Advent of SysML v2. This is a training series consisting of short videos and exercises brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kęstutis, and so far we focused on structure, parts, attributes, connections. But systems don't just exist, they do things. Today we are diving into SysML v2 behavior modeling with actions. By the end of the lesson, you will know what actions and parameters are, how to decompose actions into steps with succession, and how to control structures like loops and conditionals. If you've been following this series, here's good news. Behavior models are built almost exactly like structure models. Think about the parallels. Parts exist in space, actions exist in time. Santa sleigh contains a cargo bay, the deliver gifts action contains steps like approach house. A harness connects sleigh to reindeer. A succession orders one action before another. If you can model structure, you can model behavior. Just think temporally instead of spatially. Let's look at our model, in which we model Santa's gift delivery process. Actions are defined using action-def keywords. We see approach house, get gift, get call, and deliver gifts action definitions. Just like parts, actions can have features. The most common features are parameters, the inputs and outputs of the action. The parameters are the directed features of an action. On line 9, we see address parameter. The in modifier means the address flows into this action. On line 13, we have gift parameter. The out modifier means the gift flows out of this action. You can also use in-out for bidirectional exchange. By default, parameters are variables. Their values can change during execution. If you need a parameter that stays fixed once the action starts, add the constant modifier. An action definition is a blueprint for an action performance. A performance is the actual act of happening in the universe. We can model specific performances using action usages. Just like with parts, you can declare abstract action definitions that serve as contracts to be specialized. For example, an abstract wrap present action could be specialized into wrap with paper or wrap with ribbon. Santa's elves must wrap presents, but the specific method varies. Now let's talk about breaking actions into steps. Some actions are atomic, they just represent a single thing that happens. But often, we want to define an action in terms of other actions. This is called action decomposition. An action can have sub-actions, also called steps. And naturally, we want to specify what order these steps execute in. This is where succession comes in. A succession is a relationship that asserts this action happens before that action. Let's look at how this works in our deliver gifts action. Line 21 starts a succession chain with first start keywords. The keyword first begins the chain, and the start is built-in action representing the beginning of the parent action. Line 22 uses then action prepare for takeoff. The then keyword creates a succession. Prepare for takeoff must happen after start. Line 23 again continues with then action takeoff. Notice the pattern. Each then keyword creates a succession from the previous action. Here's an important detail. Then keyword can declare an action usage in line. These are currently just leaf actions with no definition or body. Placeholders we can refine later. Actions are rarely completely linear. Real processes branch, iterate, and run in parallel. SysML v2 provides control structures to model this complexity. Line 24 shows a for loop for child in children. This iterates through the collection of child data. For each child, we execute the loop body, approach their house, determine if they're nice, and deliver an appropriate item. SysML v2 also supports while and until loops. Inside the loop, line 26 shows an action usage with the definition approach house, but it has no name. This is common when we invoke an action definition, but do not want to reference it again. Line 27 tells that action approach house must be executed with the input set to the address field of the current child data. Next, Line 29 shows an if action. If actions branch on guard condition. They always have a then clause and may have an else clause like on line 34. Inside each branch, we invoke either getGift or getCall. SysML v2 also provides decision and merge nodes, but if actions are more concise, they combine condition and branches in one construct. Line 33 and 36 then use assignment actions to store the result. Notice line 25 declares a reference item to give, a referential feature that acts like a local variable. Finally, let's look at concurrency. Line 38 has a fork, a point where multiple threads start executing concurrently. Lines 39 and 40 list the first steps of each thread. Important to note, these are references, not declarations. The actual action usages are declared in lines 42 and 46. The then keyword originates from the fork, so both action threads start from there. Line 48 declares join j. Each thread's chain proceeds to this join point. And remember, concurrency doesn't mean parallelism. It just states that threads execute independently. This could mean any ordering or true parallel execution. You have now learned the fundamentals of action modeling in SysML v2. Actions define behavior, parameters specify inputs and outputs, successions order your steps, control structures handle branching, iteration, and concurrency. Your challenge is to prepare for takeoff action definition. Check the blog post for detailed instructions. Share your experiences and feel free to ask questions in our community forum. Links and information on Syside Cloud Access are available in the video description. Like the video, subscribe to our YouTube channel, and click on the bell icon to get notified about future lessons. Take care and happy modeling!